Hello guys, welcome to ecet series. Guys, I have already explained TS ecet 2020 paper. If you haven't gone through that videos, check out the videos also because there will be a lot, no much difference between TS and AP sets and some questions will also be repeated. Now let's get into the video. In this video, we will go through the digital electronics of AP ecet 2020. Digital electronics is a simple and very scoring subject in ECET. Here's our first question. Simplest registers only consist of. In this question, we are familiar as registers are made up of dash, but to make tricky, they asked it as simplest registers only consist of dash. The answer is flip-flops. As we know that registers are made up of flip-flops, the answer for this also becomes the same. Now let's move to our next question. Which of the following is a universal gate? NAND and NOR are the two universal gates. Using NAND or NOR gate, we can implement any Boolean function without the use of any other type of logic gate. Here both the options are correct. Uh, You will get scored for any of the option. Now let's move to our next question. X bar whole bar is a dash. X bar whole bar is known as double complement, but it is not given in the options. In key, it is given as duality is the correct option, but duality is completely a different theorem. I think dual complement is so near to the answer, so it would be the correct option. And X bar of bar equals to X. So let's move to our next question. A multiplexer is also called as dash. A multiplexer will have multiple inputs, but it selects only one input line as the output. So if we see the options, multiplexer is not a coder. It's not a parallel adder. It does not add anything. Mm, Multiplexer can be used for data selections because it selects from many data lines. It selects one data line to the as the output, so it can be a data selector. It's not a NOR gate. Now, our fifth question: a binary variable can take the values. It's not binary variable can take 0 and 1 as their values. It is a very simple question. You know that. Now move to a sixth question. Here it is given a binary number and asked to convert into a decimal number. So here we'll see how to convert this. First, you have to know this process. So let's start from here. Here it is. We have a decimal point. Okay. Now 0. To make it fast, I will do it very soon. Here 0 into 2 power 0 plus 1. Here we have 1. So here it is 1 into 2 power 1. Here we will go on incrementing this power value. Next 0 into 2 power 2 plus 1 into 2 power 3. Now we will see to the decimal points also. Plus 0 into 2 power minus 1 plus, here don't get confused, here we will having plus, not multiplication, we are doing addition. 1 into 2 power minus 2. From decimal we will go as minus negative powers, remember that. Here 1 into 2 power minus 3. Mm, Now let's get now cancel all the multiplication with zeros, as 0 into something is 0. So delete this, and here this. Now add the remaining. 1 into 2 power 3, it's 8. 2 power 3 is 8, and 1 into something is something. Plus 2 power 1, it's 2. Plus, here we have 2 power minus 2. It becomes 2 power 2 is 4. But here we have minus, so we can write it as 1 by 4 plus 1 by 8. 1 by 8. Now let's do this. 8 plus 2, 10. Plus, here if we take it as LCM, it will we get that 8 as denominator and 1, sorry, 2 here plus 1. So it becomes 10 plus 3 by 8. And if we do the calculation, we get as 0.375. To make it faster, I have done this. You can do it very easily. So the answer becomes 10.375. So the correct output answer is this. And don't make it very slow. If you be perfect, you can make it fast. You can calculate it very fast. Now let's move to our next question. Each square in K-map, Karnak map, it represents a. It is easy to convert truth table to K-map, and K-map can be converted into sum of products (SOP), and SOP is represented by min terms. So the answer is min term. The question is given on the basic line of conversion, like to treble can be converted into kmap, kmap can be converted easily into sum of products, which is represented by min term. So now let's move to next question, and remember this question and answer, because this is the most repeated question. Now let's move to final question. Circuit whose output depends on directly present input is called. In digital electronics, we have two types of circuits, namely combinational circuit and sequential circuits. And in combinational circuit, it the output depends on present input. In sequential circuit, the output depends on previous output. Previous, yeah. As you can see, sequential means this is depending upon something another done before. So it goes in a sequence manner. So it goes in a sequence manner. So you can think that in combination circuit it is a present. The output depends on present input. For example, for example, adders, and muxes, like multiplexer, demultiplexer. In sequential circuits, examples are flip flops and counters, etc. Flip flops, here you can see flip flops output depends upon present in previous output. So in this way, the answer is the answer is combinational circuits. And finally, guys, if you found this helpful, please like, share, and subscribe.
Thanks, Namaste.